Hey everyone, welcome back to another episode of Andrew and Amandeep, the show sent for Mr. Buttar. Today we're going to be taking a look at the continuity of functions. So to start us off, I'd like for you to consider this. We have a limit, and as x approaches a, we'll have on f of x here. Okay. So until now we've said, okay, well this means as x approaches a, f of x is going to approach something. Cool. But if we think about it, how is x approaching a? Does it come from the left or does it come from the right? This is never explicitly said in this little expression here. So we do this in more mathematical terms in this way. We're going to say x approaches a with a minus. This little minus here means that x is approaching from the left. So x is approaching a from the left. Okay. And now I'm sure you're all very smart. We can infer what the plus here means. The plus means the exact same thing except that it's approaching from the right. Now, of course, the minus is because on the x-axis, the left side of the axis is negative, and the right side is positive. So this is a good way to remember this. Okay, well, so now that we've defined this, we can start taking a look at what exactly an limit existing means. So we can say lim x approaches a of f of x exists, okay, if the limit as we approach from the left and the limit as we approach from the right both exist and are the same. So, well, here I've actually forgotten to add my f of x's, so let me just put those in. Equal to limit x approaches a from the positive side, f of x. So, okay, this makes sense. We can say a limit exists if it doesn't matter which side we approach it from. It could come from the left side, it could come from the right side. Either way we'll get the same answer. And okay, that's a reasonably good definition. We can say, yep, sure, that if these conditions are met, then it exists. But we're looking at the continuity of functions. What does this have to do with that? Well, this is because a function's continuity is defined based on this idea. We say that a function is continuous if, and this part is important, it's continuous if the limit as x approaches a of the function exists here, and equals f of a for all a. Okay, this is a lot to take in, so let's dive into step by step. We say that the function is continuous if this limit exists. So remember that we just defined this here. It exists if the left and the right side both exist. Okay, that's good enough. And equals f of a for all a. So this equals f of a part is kind of simple as well. We say that, okay, well x could approach a, x could get really, really close to a, and this value that we get will be equal to if x was exactly a. Yeah, that makes sense. And finally, the last part we have for all a. This just means that a could be anything we'd like it to be, and this would still be true. So there we go, that's the definition for a function being continuous. But of course, it doesn't help to just read this definition, and then you're not going to get the hang of it. So let's head on over to Desmos and take a look at a couple examples here. So this first function here, you don't have to worry about the formula I've put in. It's mostly about the graph. you can see that this function is discontinuous. It's not continuous. Can you see why? It's because, well, there's a sudden jump over here. Before we learned this definition, we would have just said, okay, there's a jump. It's not really, it doesn't feel continuous, so it's not continuous. But now we have a definition. We can show why it isn't continuous. We say that, okay, well, what if I set a to be equal to 0? Then I say, okay, when x approaches a from the left side, a is going to be negative, sorry, the limit is going to be -1. As x approaches a from the right side, the limit is +1. But look at this, we said that, okay, if the limit exists, then these have to be the same thing. In this case, they're not the same thing. This one's positive and this one's negative. So we say that this limit doesn't exist, and by consequence, the function, this, does not exist for all a. It might exist if a is -2, but it does not exist if a is 0. And so this function is not continuous. The next function let's take a look at is this one, this hyperbole. This is the rational function I was talking about earlier. If we look at this function, we'll see that, okay, there's a little weird thing going on here at 0. On the right side, x approaches positive infinity, and on the negative side, f of x approaches negative infinity. So again, if we set a to 0, as x approaches a from the right side, x tends to positive infinity, and as x approaches a from the left side, x tends to negative infinity. Again, these limits don't equal each other, and therefore the limit does not exist. So it's the same idea as this function here. Now finally, let's take a look at this one. This is the function where we might want to actually take a look at the formula to see what's going on. So, starting from here, everything's good and dandy, there's no holes or anything. It looks like a pretty normal function. But, hold on, once we reach -1, exactly, we'll see that it's undefined. So there's a hole in this function, and we can see why it's undefined. Look in the formula here, we have x plus 1 on the denominator. If x is equal to exactly -1, then this would be no good. X can't be -1, the function becomes undefined if it is. So that's why we have a hole in this function. But what does that mean for the continuity? Well, let's set a to be equal to -1, and let's take a look at our rules here, okay? So, what happens when x approaches a from the left side? Well, it's fine and dandy, because remember, limits mean we're approaching. We're not exactly at -1. We're just getting really, really close to it. Since this function is only defined at exactly -1, this is okay. It does exist. And similarly, it also exists when you approach from the right side, the positive side. So look at this, it's going to get really, really close to -1. But we're not going to exactly hit it. We're just going to get ever so close to it. And again, this still exists. Now, if these 2 points are infinitely close to -1, then they will be equal to each other. And so we can say, okay, the limit at x approaches -1 does exist. But remember, there's the second part, and equals f of a. What's f of -1 here? F of exactly -1 is undefined in this case. We can have x approaches -1, but not exactly x equals -1. And for that reason, this little clause over here in our definition is not satisfied. And so we say that the function is not continuous. Even though the limit exists, a point doesn't exist, and so it is not continuous. Anyway, that'll do it for this episode of Andrew and Amandeep. Thank you for watching. Subscribe, like for more, and if I hit 50 likes, I will ask Butari to the dance.